The deadliest climate event in history wasn't an asteroid. In 1877, a Super El Niño wiped out 50 million lives. Earth's past holds the code. The ocean holds over 90% of Earth's trapped heat. During El Niño, it dumps that energy directly into our air. What happens when planetary wind systems simply collapse? Pacific trade winds stall, shifting a massive warm ocean wall.
Ocean anomalies are surging past 2.9 degrees. The 2026 El Niño is intensifying fast. Real-time tracking matters.
One ocean anomaly is dangerous. Two together? Unprecedented. A positive Indian Ocean Dipole is supercharging this heat. A warm Pacific doesn't just heat the ocean, it bends jet streams, locking severe heat domes over entire continents. The energy released by El Niño isn't measured in gigawatts. It equals millions of megatons of raw thermal movement.
Rainfall patterns don't just shift during El Niño, they invert. Severe droughts in Asia, torrential rains across the Americas.
Normally, strong trade winds drag warm surface waters westward toward Asia. This causes cold ocean water to well up off South America. This upwelling creates the Walker circulation, a massive atmospheric loop. It stabilizes tropical climate systems worldwide.
When pressure drops in the eastern Pacific, trade winds falter. Warm water sloshes back east, flattening the ocean thermocline.
Tree ring atlases reveal a terrifying pattern. Solar cycles combined with El Niño triggered multi-year mega-droughts. In 1876, monsoon systems over India completely collapsed. Crop failures swept across 3 major continents simultaneously. Imperial grain exports continued despite empty fields. Market forces magnified a natural disaster into human tragedy. Northern China saw 3 years of zero rainfall. Over 9 million humans perished in the drought alone. In South America, the Grande Seca devastated Brazil's northeast. 500,000 died as rivers completely dried up. 3 synchronized droughts, driven by one single ocean anomaly. It killed 3% of Earth's population. 1997 brought another monster event. Global damages topped $35 billion. Extreme weather shattered local infrastructure. 2015 set a new benchmark, pushing global baseline temperatures higher. Marine ecosystems suffered unprecedented thermal shock. Each historical event left a fingerprint. Coral cores record ocean temperatures going back thousands of years.
The data shows El Niño isn't static. Extreme events are becoming more frequent as baseline ocean heat rises.
To understand 2026, we must look at atmospheric teleconnections. Ocean heat acts like an engine driving wind. When warm Pacific water shifts east, it alters the Hadley cell circulation. Tropical thunderstorms shift thousands of miles.
This shift displaces the jet stream. Instead of a steady flow, atmospheric waves warp into massive meanders.
These buckled waves create high-pressure blocking ridges. Weather systems freeze in place for weeks at a time. Under a blocking ridge, soil moisture evaporates completely. The land heats the air, creating a runaway thermal feedback loop. Simultaneously, other regions face extreme precipitation. The altered atmospheric river carries massive moisture plumes. In the upper ocean, thermal expansion raises sea levels. Coastal regions face elevated tides even without storms. Below the surface, Kelvin waves transport massive thermal energy, moving eastward across thousands of ocean miles. When Kelvin waves hit South America, they surge to the surface. supplying fresh heat to the atmosphere. This ocean-atmosphere coupling is a self-reinforcing engine. Once started, it takes months to dissipate. Global climate baseline temperatures act as the starting floor. An El Niño spike now hits unprecedented absolute numbers.
This is why oceanographers track subsurface heat storage, not just surface skin temperature. Which brings us to 2026. Sea surface anomalies in Niño 3.4 reached historic levels early in the season.
The Southern Oscillation Index sank to record negative values, confirming full atmospheric coupling.
What makes 2026 unique is the Indian Ocean Dipole coupling. Both oceans are releasing peak heat simultaneously. In Western Europe, heat domes established record temperatures early, driven by distorted Atlantic pressure gradients. Across Southeast Asia, monsoon circulation has faltered. Agricultural stress is compounding across major rice-producing belts.
In the Americas, intense coastal atmospheric rivers are forming, threatening severe erosion and flooding.
Marine heat waves are accelerating. Water temperatures in key coastal zones are 3 degrees above average.
Fisheries across the equatorial zone are seeing radical species migration. Cold water species are pushed deeper.
Global energy grids are straining under peak cooling demand. Hydroelectric power output drops as reservoirs dry. Atmospheric pressure shifts over the Pacific alter global cloud coverage, further changing Earth's radiation balance. The 2026 event demonstrates how regional ocean heat reshapes global economic supply chains. Predictive climate models were 60% unanimous. 2026 is testing the upper limits of forecaster modeling. Are we approaching a climate tipping point? When background warming supercharges natural cycles, systems become non-linear.
Amazon rainforest dieback is closely tied to El Niño droughts. A weakened forest absorbs far less carbon.
Permafrost thawing in the Arctic accelerates when jet stream waves pump tropical heat north. The global carbon cycle responds directly to these heat waves. Atmospheric CO2 grows faster during El Niño years. Scientists are deploying autonomous ocean floats to track subsurface heat. Array networks stream data in real time.
AI-driven climate forecasting can now predict thermocline shifts months earlier, giving communities time to prepare.
Preparation is key. Early warning systems reduce agricultural losses and protect coastal infrastructure.
The physics of our planet are interconnected. An ocean shift in the Pacific changes weather in your backyard. What happened in 1877 was a warning written in tree rings. What happens in 2026 depends on our understanding. Earth's atmosphere isn't breaking. It is obeying thermodynamic laws, driven by massive energy inputs.
As we track the 2026 El Niño, analyzing raw ocean data becomes critical. The science is evolving daily.
Are ocean heat cycles pushing global systems past critical limits? History tells us what lies ahead. Hit subscribe to explore more such scientific facts.